Hi everyone, in this video we're going to be doing A-level further maths 9231 paper 43 May June 2025 further probability and statistics. This paper is 1 hour 30 minutes long, so we'll try to finish within by then. So let's head on to the first question. Okay, so for the first question, we're told that a person's eye color may be categorized as brown, blue, or other. Scientists claims, okay, this is the important part, that these eye colors are uniformly distributed and hence are equally likely to occur in the population. So what he means is that the expected frequency of each of these eye colors is 1/3. Okay. All right. So, and after that, we're told that a survey of 120 people from this population found that 38 people had brown eyes, 52 people had blue eyes, and 30 people had eyes which were either blue or brown. So 30 people had other. Okay, so question tells us to use this data to carry out a goodness of fit test at the 5% significance level to test the claim. Okay, so in order to do this question, let's first draw a table. Okay, so let's write down our categories. So we have brown, blue, other. Let's write down the observed frequency. So that's basically what we counted like from like the actual results. So you can see 52 and blue, and people didn't have. Write down the expected frequencies for each of these three categories. So to do that, we're told that it was a uniform contribution. So the probability of having either of these three is the same. So in other words, having brown is 1/3, having black 1/3, and the color of other eye color that is neither brown or blue is also 1/3. So to find the frequency, we just take our population number, so 120, and multiply with the probability. So that means each of the expected frequencies for each category is all going to be 40. All right. So after all this, we are going to find our observed frequency minus expected frequency divided by expected frequency for each of the categories. So this one, just use your calculator. Okay. So first for brown, we have 38 minus 40. Oh, sorry. Forgot you had to square this. Okay. So that we can take the effect of the negative sign away because sometimes the difference can get negative. Okay, so let's continue. Like what's going on? Okay, wait. 38 minus 40 squared divided by 40, you get 0.1. For blue, you will get 3.6. For others, you will get 2.5. So these are values for OI minus EI squared over EI. Now we just have to find the summation of all these values. And this would act as our test statistic. Okay. Okay, so just add these all up. 6.2. Yeah, so this is our test statistic. Now we have to find our critical value. So in case you didn't realize, we have to use the chi-square distribution for this because of goodness of fitness test. So let's head on to the chi-square tables. Wait, yeah, this one. Yeah, so, oh, yeah, to find the critical value, you also need to know the degrees of freedom as well. So since we have two categories in here, our degrees of freedom will just be 3 minus 2, which is 3 minus 1, which is 2. And since our significance level is 0.5, 5%, our p-value is going to be 100% minus 5%, which is 0.95. So let's look under 0.95. 0.95 and 3 minus 1, 2. Okay, we get 5.991. So critical value is 5.991. So for the chi distribution, if this is your critical value, this would be your rejection region, okay, where you reject your H naught. Okay, so yeah, this is a critical value. Oh shoot, we forgot to define our hypothesis. So the hypothesis, null hypothesis is that eye colors are uniformly distributed. By the way, this is supposed to be the first step, so pardon me for this mistake. An alternative hypothesis is eye colors distributed. So since our test statistic 6.2 is bigger than 5.991, we are supposed to not reject H naught. Like we can reject the null hypothesis. So that means there is a chance that the alternative hypothesis is correct, and hence we write do not reject H, the alternative hypothesis H1. So we can hence write down there is insufficient evidence to justify the scientist's claims. So this would be our conclusion. And remember that when you're writing the conclusion, you should write it within the context of the question. So you have to be specific with your conclusion. So in this question, they told us to test the scientist's claim when the scientist said eye colors have uniform distribution. But in our case, the opposite turned out to be true. So yeah, that's why I wrote it this way. And yeah, we have actually come to the end of this question. Let's head on to the next question. Okay, so for this second question, we're told that a farmer is investigating whether new fertilizer will increase the yield of tomato plants. Farmer selects 40 tomato plants at random and gives them the new fertilizer. The crop mass, X kg of each of these 40 plants is recorded. Farmer selects a further 60 tomato plants at random, gives them a standard fertilizer. Crop mass Y kg of each of these 60 plants is recorded. The results are summarized as follows. Yeah, so we're given the sum of the crop mass of the new fertilizer in here is 168. We're given the x squared sigma. So like the crop mass has been squared and it has been summed up to give 720. And we also did, and the question also gave us the same for the standard fertilizer, which is represented by y, as you can see. So now, the question told us to find a 90% confidence interval for the difference in mean crop mass associated with each type of fertilizer. Okay, so to find your confidence interval, there is this easy way to determine the formula if you ever forget. All right, so let's use the formula that we used to find the what you call the population mean. Wait, no. So I'm yeah test statistic, like when we are instead trying to do a hypothesis test of whether or not the difference in the means of the two populations is um, more than this or not equals to zero. Yeah, so let's take our that formula. So that formula is basically just x bar minus y bar, the sample mean difference minus the population means difference over the standard error. So the standard error would just be the sum of the variances of each of the populations squared. So in our case, that would be sample variance of x over the number of x's. So that's 40, and then plus this. Yeah, so this is the formula. Now we're just going to rearrange for this. Okay. So let's first multiply by the standard error. And now we can make this a subject. So this is our formula as for why I left the sign like this. Um, the sign can either be plus or minus because there's the word interval in it. So obviously there would be a lower bound and an upper bound of this confidence interval. Okay. And one more thing to note is that this is like not the correct explanation. It's just a way to derive the formula in case you forget it. So in no way is this like meant to explain what the confidence interval is. It's just a way to derive it. Okay. All right. So confidence interval. So you take a normal distribution. Is basically the range of like a mean or the difference in mean of two populations. Yeah. So like for a certain critical value, so like for certain probability. So this is your confidence interval, and these two will be our critical values. So we need to find out what those critical values are. Okay. So the critical value in here, let's call it Z, is this same Z in our formula. Okay. So to find out Z, you first have to take 90% and plug it into this formula, and you should solve for alpha over 2 because as you can see, it's a two-tier test, right? So 90 divided by 100 plus 1 divided by 2, you get 0.95. So the significance level of Z is 5%. So our p-value is 0.95. So let's take a look at our tables, normal distribution. So p-value 0.95. We have it here. Z value is 1.645. Yeah, so this is our value, our critical value. Now put on here. This will obviously just be 1.645. This is just for reference, by the way. Okay, and with that, we can start finding our X bar. So X bar, very obvious, it's just sigma X over NX. So 168 over 40 over 2. And Y bar would have sigma Y divided by, which is 60. You'll get 19 over 5, which is 3.8. Okay, all right, now let's find our standard error, the exact value. So SX, check the formula sheet for that. Okay, so yeah, you have it right here. We're gonna use the second one because we have this and this, but not this. We don't have, so we're gonna use this one. So 1 over, we're just gonna find these directly. So just type into calculator, 1 over x is 40. So 39 times sigma x squared. So 720 minus 168 squared over nx, which is 40. So we get a nice answer of 24 over 65 for S for the sample variance of x. And for this in the denominator, you multiply it with 40. Let's do the same for the variance, sample variance of y. So for y, we have 60. So 59, 900, 228, 60. So we will get 168 over 295 times 60. So just type it into the calculator. You get square root 359 over 19175. Let's just keep it this way. And now we can find our confidence interval. 2 minus 3.8 plus minus z, which is 1.645 times square root of 359 over 19175. So let's find the lower bound first. So we're going to play a minus sign first. So 4.2 minus 3.8 minus 1.645 square root 359 over 19175. So first answer, we get 0.175. And then second answer, just replace the minus sign with a plus sign, is 0.625, both to 3SF. So yeah, these are our answers. So 175 and 0.625. Okay, I think we're good. We can head on to the next question. All right, so for this question, we are told a continuous random variable of x has a probability density function f given by this. So as you can see, fx is a piecewise function. So for different values of x, we have two different PDFs. So for x from 0 to 1, we have kx, and 1 to 8, we have this. So the values of x is from 0 to 8. So k is a constant. So first part, we need to show that k is equals to this value. Okay, so to show that, we have to make use of the fact that the total area under the graph of a PDF is equals to 1, because the area under the PDF represents the probability of the random variable. So if you take the PDF of the whole graph of all the values of x, you'll obviously get 1. So let's find the area for this first. So just integrate from 1 to 0, kx dx, and then obviously plus it with the area under this part. So since it's from 8 to 1, limits will be 8, 1, k times 8 minus x dx equals to 1. So to integrate this, just raise the power by 1 and you divide by the new power. So you get kx squared over 2, 1, 0. And then for this, I also do the same, okay? So okay, I think we remove this k out first, and we just integrate 8 minus x. So integrate x, you get 8x, then minus x, you get x squared over 2, 8, 1. Now just plug in your limits. So you plug in 1 into kx squared over 2, you will get a over 2, and then you plug in 0, just get 0, plus k times 8, you get 8 times 8, that's 64. So 64 minus 8 squared over 2, sorry, 8 squared over 2 minus 8 times 1 plus 1 squared over 2. So you get 49 over 2 equals to 1. So adding these up, you'll get 25k equals to 1, 50 over 2k, and hence you get k equals to 1 over 25. Yeah, so the right shown because they already give us the result and we have to derive it. Yeah, so with that, let's head on to the next part. Okay, so here we're told to find the median value of x. All right, so to do this question, I believe, let's see the next part. Okay. Let's find the CDF of x. It'll be helpful. So to find the CDF, we take our first piecewise function, the first function, okay, and then we integrate it. So to integrate the piecewise function, it is slightly different. Okay, so instead of x, we have to use a dummy variable like t, and we will differentiate with respect to that. And as for the limits, we only take the lower limit, and the upper limit would just be x. So limits are x and 0. So integrating this, get kt squared over 2. So x and 0, you'll get kx squared over 2. All right. Okay, and now to find the second CDF using our second piecewise function, we should first substitute the lower limit of the domain of x. So in this case, it's 1. So we're going to put a big X, a big F, sorry, 1. You will obviously just get k over 2. And and then now, to find the second piecewise function, you just add f1 plus the integral of 1, because the lower limit's 1, all the way to x of k times 8 minus t. Just, yeah, the reason is just like the previous part. Okay, so let's evaluate this. We remove the k, just integrate 8 minus t, so you just get 8t minus t squared over 2 x1. You would get k over 2 plus k times 8x minus x squared over 2 minus 8 times 1, that's minus 8, minus minus, so plus 1 squared over 2, so 1 over 2. All right. Oh, shoot, I forgot. Yeah, 1 over 25. So this is just 1 over 50. Okay, so 1 over 50 times 1 over 25 times 8x minus x squared over 2 minus 8 plus half. You get minus 15 over 2. Okay. Let's just straight away simplify this. You get minus 1 over 50 x squared. 8 times 1 over 25. You get plus 8 over 25x. 150 plus 125 times minus 15 over 2. Yeah, then, yeah, you get 7 over 25. So this is the second CDF. Now we can like just substitute any value of x and equate it to 0.5. Since the probability of the median value since it's halfway, it is obviously 0.5. So let's choose this equation. I'm feeling it's going to be within the range of 1 and 8. So let's substitute x equals to m. Okay. So x equals to m, yeah, times minus 50. You get m squared times minus 50 minus 16m. 2, you get plus 14. Let's do 0. Now I think can factorize this. So 1 minus 16 plus 14. Oh, wait. Okay, never mind. Yeah, so you have to use your calculator to solve, and if you see that the solutions aren't within the given range of x for the respective PDF. So in this case, between 1 and 8, then we have to reject. So let's try the second one. Okay, so give us 125. So that's x squared 50 goes to half. Get what the heck? Wait, sorry. You multiply 50, you get 5. Okay, give me a while. Sorry, everyone. Yeah, I forgot to equate the equation to 0.5 or 1/2. So, as I was saying, you have to substitute x equals to m. So you have 1 over 50 m squared plus 8 over 25 m minus 7 over 25 equals to half. So I'm just gonna move this half over to the left-hand side and get rid of the denominator at the same time. So you're supposed to be getting m squared minus 16m minus 7 over 25 minus half times minus 50. You get plus 39 equals to 0. Solving this, you get m minus 13 times m minus 3. You get two solutions, m equals to 13 and m equals to 3. And we should reject m equals to 13 because it is not within our range. The max value of x is only 8. So this would be our final answer for this part B. Let's head on to the final part. Okay, so now we are told that the random variable y is defined by y equals to the cube root of x. So using this, you have to find the PDF of y. Okay, so first of all, let's get rid of the cube root and express in terms of x. So x is equals to y cubed. Okay, so to start off, let's write down the CDF of x, the cumulative distribution function. So we write this big fx. Okay, so for 0 to 1, we have kx squared over 25, which is just 1 over 50 x squared, 0x 1. And then the second one is this function, minus 150 x squared plus 825 and 725. Oh, sorry, x. Yeah, and 725. Yeah, so this was the reason why we found the CDF in the previous part, so that we can use it in this next part. So whenever you're doing that type of question, like in the previous part, check the next part, the subsequent parts. If they have this type of question, then form the CDF in the previous part, solve the question using that. Yeah, it's just a little tip that I have. Okay, so yep. Oh, sorry. Yeah, for like the proper way to write is from 0 and 1. So the 0 is going to be x less than 0. For 1 is going to be x more than a. Yeah, so this is our CDF for x. Now let's write down for y. So for y, we're going to let it be g big Y. Okay. So it's actually going to be the same values, but instead of x, we're going to re-express everything in terms of y. So all these x's will just become a y cubed. So instead of x less than 0, this will be y cubed less than 0. And then instead of 1 over 50 x squared, this is going to become 1 over 50 y cubed squared. So in other words, 1 over 50 y squared. This is going to be y cubed between 0 and minus 1 over 50 y to the 6 plus 8 over 25. The y would become y cubed minus 7 over 25. This is going to be 1 cubed and 8. And finally, I have y cubed more than 8. Now let's get rid of the y cubed in the domains. Okay, so this is the cleaned up version. So 0 would be for y less than 0, 1 will be y to the power 6. It will be between 0 and 1 for y. It's 1 over 50 y to the power 6 plus 8 over 25 y cubed minus 7 over 25. You will get y is between 1 and 2 because the cube root of 8 is 2, and so on. Yeah, so this is our final CDF, but the question wants us to find PDF, so let's differentiate each CDF of function. So let's differentiate this one. Okay, you'll get 6. You just bring down the power times 150 y to the power 5. And then you divide by 2, you get 3 over 5 y to the power 5. And you get gy 6 times 150 over 5 plus bring down the power 3 times 8. It's going to so like 8 over 25 y squared, and then this constant term will just go away. So simplified is 3 minus 3 over 25 y to the power 5 plus 24 over 25 y squared. So the final answer, we have to present it properly. We cannot just leave it like this. Okay, so we can write it in this format, just like in the question. Okay, so write down the PDF as well as the domain that's valid for. So in this case, is from 0 inclusive to 1. And the second one, minus 3 over 25 y to the power 5 plus 24 over 25 y squared. It's valid for 1 to 2. Let me see. Yeah. And then we write 0 otherwise. So yeah, there should be, let's check one last time. Okay, let me just check whether my working is all correct. Yeah, yeah, I think so. Yeah, so this would be our final answer for this part of the final part of this question. Let's on to the next question. Okay, so for this question, we're told that a researcher claims that older people take longer to react to a sudden loud noise than younger people. To investigate this, the researcher randomly selects 6 people over 50 years old. Yeah, so you can see in here the 6 people, 1, 2, 3, 5, 6, and 8 people under 25 years old. Record their reaction times in milliseconds to a sudden loud noise. The reaction times are as follows. So these are all the reaction times of all the participants that were randomly selected. And we're told using all this information to carry out a Wilcoxon rank sum test at the 5% significance level to test the researcher's claim. Okay, so first of all, just like any other statistical test, we're supposed to state our null and alternative hypothesis. So the null hypothesis, okay, the researcher wants to research whether the old people take longer to react to sound, loud noise than younger people. So we're gonna call the median reaction time for old people, like for those over 50, be my, and for those under 25, be mx. Sorry, not mean, median. The Wilcoxon rank sum test, we don't assume any distribution to it, so we always use the median as a parameter. So null hypothesis would be my equals to mx. Then the alternative one would be what the researcher is claiming. So is they saying, oh, people take longer to react. So if they take longer to react, obviously the median time for them would be more than for the younger people. So my is more than mx. So because we are seeing whether one is more than the other, okay, we're not seeing whether they are equal to each other or not. This is a one-tailed test. So take note of that. And with that, we can start our test. Okay, so to do this, we're going to rank each of them. Okay, so um, let's check the formula list. Okay, so like then we can see what we need. And then it's also useful for you if you forget what to do. Okay, so two sample size M and N, Rm, it's the sum of the ranks in WRM. Yeah, okay, so let's just rank all of them first. Okay, so yeah, let's look for the lowest number first. So 178, 181, 183, 192. Oh, okay. Yeah, they actually for under 25, they're all arranged in ascending order. So 178. Let's also write down the population belongs to either Y or X. So obviously this is from X, so this number one. So put a tick mark, 181. Two, also put a tick mark, 183. That is 3, 1, 2. That's 4. And then over 50, we have 198. That's 5. 203. That is from here, so 6, 209. That is 7. 212. Okay, 212 is from over 50. So this is 8. And then 217. Yeah, 217. That is 9. And then we have 223. Okay, 223, that is from under 25. So that would be 10. Okay. And then we have 229. Okay, 229. That is 11 from older people, over 50. And then we have 229, 231. 231, that is from below under 25, so that's X. So this is 12. We have two more, 235 and 242. So 235, 242, they are both from the older people, so 13 and 14. Okay, let's see if all our ranks are correct. So this is 6 people plus 8 people. Yeah, that's 14 people together. Yeah, so this is all our ranks. Now we're gonna find what we're required to find for this sum test. So the formula sheet already gave you some hints. So our critical value is W, and W is the smaller of Rm and this expression. So Rm is the sum of the ranks of the items of sample size M. And then the size M has to be less than or equal to N. So in this case, M is going to be Y because 6 is less than 8. So Rm just going to be 5 plus 8 plus 9. I'm just going to write down 5 plus 8 plus 9 plus 11 plus 13 plus 14. You get 60. And then we also need to find M times N plus M plus 1 minus M. So M times N plus 1 minus Rm. We get M. Oh yeah, M is the lower one, right? So 6 times N is the bigger one, 8 plus 6 plus 1 minus 60. You get 6 times 8 plus 6 plus 1. Yeah, you get 30. So W is going to be the smaller of either of these two. So W is 30. So this is our test statistic. Now we need to find our critical value. So to find the critical value, we need to know whether our test is two-tailed or one-tailed. So as I said previously, it's one-tailed. You can head back to the part if you want to know the explanation. Okay, so yeah, one-tailed. Our level of significance is 5%, so 0.05. One-tailed. Okay. Our M value is 6. So look under here. This and N is 8. Okay, so N is 8. Okay, 31. Yeah, so our critical value is 31. And unlike our parametric tests, like where we assume like the data follows a certain distribution, here we don't. So if our test statistic is less than the critical value, we have to reject H naught. So you can write down since 30 is less than 31, do not reject H naught. I mean, do not reject the alternative hypothesis. Okay, so researcher claims, okay, yeah, so that means there's a chance that older people, they do take longer to react. So the researcher might be correct. So we can write down sufficient evidence to support. Okay, I think you can use justify to justify researchers just claim. Yeah, so we can write this down as our conclusion, okay, for this question. So yeah, we have come to the end of this question. Let's head on to the next question. Okay, so for this question, we are told that the doctor is investigating concentration of blood glucose Patients at risk of developing type 2 diabetes where blood glucose is measured in appropriate units. Doctor claims that a particular intervention reduces the concentration by more than K units on average. This is important. A group of 8 at-risk patients selected at random. Each patient followed the intervention for 6 months. Blood glucose concentration before and after the intervention are given in the following table. Yeah, so this is the data for each individual patient, okay? And the doctor claims that this reduces the concentration by more than K units. So to find like the reduction, just find the difference between the two values on the table for each patient. Okay, so for the first part, you're told to use a t-test at the 5% significance level to find the range of values of K, for which the result of the test is to reject the null hypothesis. Okay, so to do this question, let's just do it, like how we usually do it. Like, yeah, so let's first state the hypothesis. So, okay, first hypothesis would be that okay, you know what? Let's not write down the hypothesis first. Let's find out all the variables first, okay? So we have to test like whether the doctor's claim is true. He says the concentration reduces by more than K units on average. So that means for each patient, like the difference between these two values, the average, he says, should be more than K. Like when you add them up and divide them by 8, you're supposed to get a value more than K. So hence we have to use the paired t-test. So let's find out all the values of D. So we're going to make any reduction positive, okay? Right, so reduction is positive, okay? So 183 minus 164, yeah, 19 for A. For B, 165 minus 148, you get 17. For C, 172 minus 164, you get 8. D, 165 minus 149, you get 16. And then E, 143 minus 134, you get 9. F, 176 minus 153, you get 23. G, 161 minus 155, you get 6. And finally, for H, 153 minus 148, you get 5. So these are values for D. Now let's find all the things that we need. So sigma D, so you just add up all these values. The sample mean, so D bar, yeah, that's just 1.3 divided by 8, you get 12.875. And the sample variance, let's call it SD squared. We have 1 over n minus 1, so that's 8 minus 1, so that's 7 times sigma squared. Okay, sigma squared is just 19 squared plus 17 squared plus 8 squared plus 16 squared plus 9 squared plus 23 squared plus 6 squared plus 5 squared. Okay, 1641 minus, just check your formula sheet and the probability and statistics. Yeah, so this same formula, or you can use this formula, it's up to you for this question. So sigma x whole thing squared is 103 squared over 8. So Putting all this together, get 2519 over 56. So this is SD squared, the the variance, the sample variance. Now we can find our test statistic. So T is gonna be D bar. Okay, that's 12.875. Okay, never mind. Let's define our null and alternative hypothesis now. So null hypothesis is gonna be that mu of D is equal to 0. So that means there's like no change, no reduction, or yeah, increase in the concentration. And the alternative hypothesis would be the doctor's claim that the reduction is more than k units. So we set reduction to be positive. So yeah, more than k. Oh, so since this is more than k, this is also mu d should be equal to k. Yeah, so yeah, take note of this when you're forming your null and alternative hypothesis. Like the number should be the same for both. And with that, we're ready to find our test statistic. So it's going to be d bar 12.875 minus mu d minus k over the standard error, that is the sample variance over n. So square rooted, so sample variance is 2519 over 56 times the number of, what you call, patients. So that's 8, whole thing square rooted. Let's see if we can simplify it. Yeah, we can. Let's just leave it like this. Okay. Yeah, so this is a test statistic. Now let's find the critical value. So since it's a t-test, find the critical value, you need two parameters. One is your p-value, which is very obvious. Like according to our hypothesis, since we're finding out whether mu d is more than k, not whether mu d is equal to k or not. This is going to be a one-tail test because we're only focusing on the upper tail. We're not focusing on the bottom tail. So it's just going to be 100% minus 5%, which is equals to 95%. So p-value is going to be 0.95. And as for V, since we have 8 patients, so 8 minus 1, that is 7. So parameters are 0.95 and 7. So 0.95 is here, and V equals 7 is here. Okay, so this is a critical value, 1.8, 1.895. So 1.895. And they told us to reject the null hypothesis. So recall, like when do you reject a null hypothesis? So I've drawn the distribution here. So this is a critical value. And we know like for this test, t-test, z-test, we can only reject h naught when the test statistic is more than the critical value. All right, so we can say that our t is more than or equal to 1.895. So we can start solving for k. So 56 times 8, we 4 for 8, more than or equal to 1.895. 12.875 minus k is more than 1.895 times 2519 over 448. K would just be, minus K would just be 1.895 times 2,519 over 448 minus 12.875. You would get K is 8.3815. And to get the final inequality in terms of just K, to 3SF, you'll get K is less than or equal to 8.38 to 3SF. Okay. Yeah. So yeah, this would be our final answer for the first part. Oh shoot, sorry. Let's head on to the last part. Okay, so for this last part, we have to state an assumption. Sorry. Okay, we have to state an assumption necessary for the test in part A to be valid. Okay, so basically, what they're asking for in this question is for one of the conditions that that you need to fulfill, that the data is to fulfill if you want to use the test. So obviously one of the data, so one of the conditions is that the population differences, there's a keyword here, population differences. Since you're finding the difference, not the population itself, must be normally distributed. Yeah. So yeah, this is a final answer for the entire question. This was this last part. Let's head on to the last question. Okay, so for this question, we are told that a bag contains 7 red balls and 3 blue balls. Kieran selects 2 balls at random without a placement. So he does not put back the ball after he selects it for the first ball. Okay. The number of red balls selected by Kieran is denoted by X. So number of red balls selected is X. And number of different colors present in Kieran's selection is denoted by Y. So, okay, so these are our random variables X and Y. So the first part, we need to find the probability generating functions for X as well as for Y. Okay, so to do this question, we have to first find the values of each random variable. So for X, it's the number of red balls, okay? So yeah, it's possible for you to have 0 red balls or just 1 red ball or maximum 2 red balls because we're selecting 2 balls at random. Okay, give me a while. Okay, so now we are going to find the probability for each of the values. So the probability of X being equal to 0. So like no red balls, all blue balls, okay? We have 3 at first, so 3 over 7 plus 3, that's 10 times 2 over 9, because there's only going to be 2 blue balls and 9 balls in total. So you type into your calculator, get 1 over 15. And now let's find for probability of X equals to 1. So you either select a blue ball first and then a red ball second. So 7 over 9 then plus 7 over 10 red ball first and then a blue ball. So for this, you would get 7 over 15. And then for X equals to 2, that means both of them are red. So there's 7 red balls, so 7 over 10 times 6 over 9. 7/10 times 6/9, 7/15. Okay, so to check whether probabilities are correct, you can just add all of the three probabilities and see whether they add up to 1. So in our case, they do. So we can write down GXT. So to write your probability generating function, you put your probability of the random variable at the front as a coefficient, and then you put the term t to the power of whatever your random variable is. So since this is the probability of p x equals to 0, the power of t would be 0. So this would just be a constant term. And then for p equals to probability of x equals to 1, that's 7/15 times t to the power of 1 plus 7/15 times t to the power of 2. So this is the probability of when x equals to 2. Yeah, so this is how you form a probability generating function. So this is the one for x. Now let's do the same for y. So for y, the number of different colors. So for different colors, both of them can be the same color. So all blue or all red. So 0 colors. Oh wait, no, less. Oh wait, sorry. There's only one color. That's the case. Or 2. Yeah, 1 or 2. You cannot have 0 different colors. Yeah. Yeah, so this is all the probabilities for y. So probability of y equals to 1. So that occurs when both balls are either red or blue. So let's find the probability of the case when both of them are red. So that's 7/10 times 6/9. Plus the case when both balls are blue, that's 3/10 times 2/9. So 6/9 plus 3/10 times 2/9, 8/15. And let's not, find the probability of y equals to 2 manually. Okay, we can just subtract this probability from 1. You get 7/15. So our probability generating function for y is 8/15 t to the power of 1 plus 7/15 t squared. Yeah, so these two are final answers for the first part of this question. Let's head on to the second part. Okay, so for this next part, we are told that the random variable z is a sum of the number of red balls and the number of different colors present in Kieran's selection. And he claims that the probability generating function of z is equals to gxt times gyt. So we have to explain why Kieran is correct. So basically, if like we have this random variable z and it's a sum of our x and y, by default, this should be valid. But since the question says it's incorrect, so the only probable explanation is that x and y are not independent. So I'm going to elaborate more on this right now. Okay, so let's take the values of z. So the sum of the number of red balls and a number of different colors. So you can have 2 red balls and 1 different color. So I think that's 3. So yeah, as you know, 2 red balls and 1. Yeah, sum of the number of red balls, that's 2 plus 1. You have 3. And then you can also have just 1 red ball and 1 blue ball. So that is 2 different colors and 1 Um, yeah, and one color. Wait, what am I saying? Yeah, so you can have two different colors and one red ball. So yeah, one plus two, you get three. Yeah, so as you can see, for both cases, yeah, these are really the only uh, two cases we have. Oh, another case, no red balls, both blue balls and different color. So that's one. Yeah. Yeah, these are the only possibilities. Yeah, so we can only have these two values. And if you do like multiply them, the highest degree of your GZT is going to be square times square, which is 4. But we already know that 4 is the possible value for GZT. So that is another way to look at it. Okay? Yeah. So in short, yeah, this is the answer. I just gave a more detailed explanation for those of you who may not like understand. Yeah. So with that, turn on to the final, the next part. All right, so here they have told us to find the probability generating function of z expressing an answer in a polynomial t. So we have to expand out our answer, or better not. Okay, so yeah, as usual, let's find the values of z. Okay, so z, can we have zero? It's the sum of number of red balls and number of different colors. Okay, so to do this, let's take one scenario where both of them are red balls. So you have two red balls and only one color. So that's three. And then you have one red ball and one blue ball. That is one red ball plus two colors. That's also three. And for Z equals, and for both blue balls, you need to, sorry, you have zero red balls and one color. So that is just one. That's just one. Okay? You cannot have one red ball and one different color. Yeah. So yeah, I think these are all the values of Z. So yeah, I don't think Z4 exists. Okay, Z square also doesn't exist. You cannot have one red ball and one different color. Yeah, that's also not possible. Yeah, so these are our possible values of Z. Let's find the probability of each one of them. So for Z to be equal to 1, uh, we can have one different color or one red ball. Wait, no. One different color and no red balls. So both of them must be blue balls. So that's basically the same as x equals to 0, right? Both of them are blue balls. So that is going to be 1 over 15. And then for b, z equals to 3, we can have two red balls and one different color. Yeah, so basically both of them red balls. So p x equals to 2, that's 7 over 15, and then plus 7 over 15, and then we can have one red ball and two different colors. So yeah, one red ball, that is also 7 over 15. So that's just 14 over 15. And to check whether probabilities are correct, again, you can just add the two probabilities up for z equals to 1 and z equals to 3 and see whether they add up to 1. So for our case, they do. So we can write this as a final answer. GZT equals to 1 over 15 times t to the power of 1 plus 14 over 15 times t cubed. Yeah, so this would be our final answer for this part. Let's head on to the final part. Okay, so for this last part, we need to use the probability generating function of z to find the expectation of z. So this question is very simple. Just refer to your formula sheet and yeah, go on the probability generating functions and you see to get the expectation, you have to find the derivative of the PGF and substitute t equals to 1. So let's do that. So let's differentiate probability generating function of z. So that is 1 over 15 plus, yeah, bring down the power 3 times 14 over 15 times t, 3 to the power of 3 minus 1, that's t squared. So you get 1 over 15 plus this 1 is 5, 14 over 5 t squared. And EZ, that's just G prime Z1. So yeah, just sub t equals to 1, you get 1 over 15 plus 14 over 5 times 1 squared. Type into a calculator, you are supposed to get 43 over 15. Yeah, so this is a final answer for this part as well as the entire question. And we have also come to the end of this paper. So I hope you found this video helpful. If you did, please make sure to like and subscribe to this channel for more future past paper solving videos and tutorial videos of A-level maths and further maths. If you have any questions, doubts, or any future video ideas or any feedback, whatever it is that you want me to know, leave it down in the comments below. And please head on to the posts tab on my channel to register for tutoring for A-level maths and further maths. And I'll see you again next time. Okay, thank you.